Okay, these are the notes in the video that I promised on Chapter 10. And what I was trying to do, my sort of value added to this enterprise, is to show how to get the data that was used in this chapter for a different region. And I picked, of course, Thurston County, Washington, which is where we are. And after you get this data, you'll be able to do a zonal analysis showing how crops vary across the watersheds. And here's the usual setup stuff. Nothing of any real interest here. So part of this project went very easy. The author of the text suggested that we could use the Cropscape R package to get crop raster data, and I did that. In this designation, the area of interest, State 53, County 067, that's Thurston County, Washington, and that's for 2020, and here's for 2010. So getting both the 2010 and 2020 cropland data was really trivial, very easy. The interesting part came when I tried to get watersheds data. And in this document, I'm only describing where I got the final successful result. I actually tried Department of Agriculture data from the state of Washington, and that failed for a totally different reason, and I never did fix that. So I decided to go get the data from the national database, and among the things that were downloaded, according to the author's suggestion, was the NHD Plus tools. And when I looked at this, the things that came with NHD Plus tools, there was a function download underscore WBD, which would get the entire national watersheds database. And I stored it in working directory current /WDD. And as you can see later, I actually moved the data to the root of the current working directory. And that is a geodata package. Now, a geodata package, to get data out of it, a geodata package always contains a bunch of different layers. So you need to use st_layers to actually see a list of the layers. And that is what I did here. And then I displayed the list of layers. And oh my gosh. Tell you the truth, I don't know what any of these things are. And I just want the watersheds data. So what do? Well, I asked ChatGPT. And you can see the conversation here. And we'll go look at that. Open link in new tab. And it says the terms HUB10 and HUB12 likely refer to different levels of hydrologic unit codes used by the United States Geological Survey. And it says this is a hierarchical system. And HUB10 and HUB12 likely refer to the 10-digit and 12-digit levels of HUC codes, respectively. The 10-digit codes are typically used for larger watersheds. Okay. While the 12-digit codes are used for smaller subbasins and streams. Well, that's not what I wanted. So I know now that what I need is HUB10. Okay? So here's the way we get HUB10. It's st underscore read, the name of the geodatabase, in quotes, followed by the name of the layer that I want, in quotes. So I save that file as wsheds.rdata. Okay, so now what you have to do is intersect the national database with the Thurston County SF object. And of course, to do that, it is important that, first of all, when you're getting a combination of a raster data set with a vector data set, you always transform the vector data set so that it has the coordinate reference system of the raster data set. And I did that here. But then it blew up. Oh boy. Okay, so let's look at what ChatGPT said. And this is really kind of interesting. A couple points are interesting in it. So let's take a look at that. Oops, that's the last one. And I told it that I've executed the following command. The st underscore read. And I was just doing this to sort of bring ChatGPT along into what I'd done, even though I knew how to do this part ahead of time. And in fact, as you notice, ChatGPT did not warn me that I needed to do the coordinate reference system transformation of Thurston underscore SF. This is really incorrect code, okay? Because unless you do the coordinate reference system transformation, this thing will just fail. This code would fail completely. Okay, but what I really wanted ChatGPT to do was tell me how I could solve the problem that I'd encountered in trying to intersect the two. And it suggested a couple things. It says use the check the validity. And I had no problem with Thurston underscore SF, but I had the problem with st is valid from the SF package. The function will return true if the object is valid and false otherwise. And it said that I could possibly use the function st underscore repair. Well, that doesn't exist anymore. Maybe it did exist at one point, but at this point, that function is not available. However, this one, st underscore make underscore valid, is available. So that is how I finally solved the problem. I did the val check and the validity check and stored the results in val check, and there's a lot of results. And if you get nothing but a vector of truths, then your data is okay. But I wanted to do to see if I had some bad data, and yes, st underscore is underscore valid found 10 failures. And then I used st underscore make underscore valid to make wsheds repaired. And it says then that the sum of not val check is 0. So that after you apply the make valid function, you've eliminated the errors. Finally, I'm able to get the Thurston underscore watersheds by the intersection of the Thurston object with the watersheds repaired. And here they are. You recognize the Thurston County. Okay, so now that you've accomplished all of this, you could take these resulting files and you could do a zonal analysis, and you could see how the crops in this watershed differed from the crops in this watershed and so on. Okay.